sheets we pass around, that's a database we're going to use for today's workshop. We're going to create, for the first half of the workshop, we're pretty much going to design the database, teach you the very basics of how to design a database. And then for the second half, we'll be touching upon SQL or SQL and teach you how to create queries and get data from the database that we just created, all right? So I know some of you guys are looking for chargers and see if you can, if you have a low battery or something. For the first half, we won't really be using computers. We'll just be more like a lecture kind of thing. And you can you're gonna need a sheet of paper and pencil to do the database design, all right? For the first half. After the first half, we're gonna take a break, and you guys can grab snacks and stuff. After that, like 10 minutes, and we'll come back, and then we'll do the second half, which is the SQL. And for that, you will need a laptop with you, all right? And again, we also announced that you need to have installed PostgreSQL. So if you don't have it, you still feel free to follow along with the presentation. If you do have it already, that's great because you can just enter all the queries you're going to do and see it live. All right.
On the laptop, onto an Excel sheet.
It's online. Yeah, for online.
That's
I'll
the website.
forward it to you for Wix.
No, because there are people there asking for the sign-in sheet.
Oh, just show it here where they can go to
Okay.
sign in.
So again, one last time for signing in, just go to the UP website, hit sign in, and fill out the form, all right? So we're still getting a couple of questions, so just to make it clear.
Okay, you can tell them that
Yep.
if they're having a hard time hearing or following you, everything you're saying is being recorded live,
Okay.
and they can go on to the streaming site, so they can
Okay. Got it.
it's DVR, so they can see previous things
I
that
see,
you've
I see,
said.
okay. Yeah, so what we're setting up right now is a recording. So like we said before, we're trying to record all our workshops. So if you miss anything or you want to review something, you can always check out the video of this whole thing later on. It'll be up on our YouTube page. All right?
Link them to the YouTube page. If you
Okay.
can, if
Here
you
at the
can,
end.
so no, but so they can see it now, because they have access to it right now. So if they miss something, they can go back and see it.
Oh, okay. So what's the YouTube page?
It should be just Google. It should be just YouTube. If you
Is it slash, like whatever?
slash UPEFIU. Shit.
It's let me turn this one.
Let me just,
But it's recording on mobile.
yeah, everything's being broadcasted. Let me just guarantee that it's actually doing it. Where are you going to be putting the...
What?
You're going to have everything on that screen, right?
Pretty much, yeah.
Okay, good. Sorry, I'm taking the chair first.
SQL.
Mhm.
Do you download the installer or the graph something? Because the guy's downloading it right now and he asked me.
Download the installer.
Because he's like, there's a download the installer bar and a download the graphic something bar.
Is it a download all? Is it download everything?
I don't think so.
Installer. Yeah. Very cool. Does it show like this? Oh, can they see the next?
Huh?
Can they see the
Everything you're doing now, they can see.
No, see this stuff.
Everything you're doing now, they can
Cool.
see.
Oh, I see. Okay.
I'm just verifying that this is doing it live. See? Shit, I forgot to choose the
Yep, there it is. All right, guys, so before we start, we want to take a little survey. How many of you guys here are taking databases right now? Awesome. All right. How many of you have taken databases before already? Cool. And how many of you are looking to take databases sometime next semester or so? Sweet. So for all of you, this will be amazing because what we base this out of is the curriculum that we use, professors use here on campus. It's for the CS curriculum, but if you're in IT, you're going to see probably more than you were going to see in that class anyway. So you'll learn some additional stuff through the presentation. And same thing if you're in MIS, you'll see a lot of cool stuff that you probably won't see in the MIS class.
Can I make a quick announcement so we can find the page? Can I make a quick announcement? Guys, you can follow along if you're having a hard time hearing in the back. With the live stream is up right now, just go to YouTube and search Upsilon Pi Epsilon. Everything with the spaces and all. And you'll scroll down and you see a face that's purple with nothing on it. Just click that. And it'll be the web development workshop because I forgot to rename it.
But yeah, I try to speak my loudest. This is the first time we have an event in this room, so it's kind of different. So moving on, as some of you might know, this workshop's being hosted by UPE, ASI, WIX, and AIS. ASI is the Academic Success Initiative. They host a lot of professional development workshops, and they also have free tutoring. So if you guys need help with any of your programming classes, even math, physics, anything like that, you can go to them and they'll help you out. Just make sure that you schedule an appointment with them, and they'll be more than happy to take you. And then we also have Women in Computer Science. They also host a bunch of different events, and they're working with us a lot this semester. And Association for Infosystems, that's mostly for MIS, and that's here in the College of Business. And they also host a lot of info sessions as well. So now a little bit about me. My name's Cesar. You've probably seen a couple of emails from me over the last few weeks. I'm a computer science major. I also have some background in graphic design. I'm a software developer right now for Panthersoft. I'm the president of UPE, and I also help out with the outreach through Google Ignite CS that we do every Wednesdays here on campus. And we go to different schools and we teach kids basic programming. It's a really rewarding experience, and it's a really fun thing to do. All right, so this is the structure of the workshop pretty much. Like I said before, first half's gonna be database design. Second half's gonna be SQL. So we'll start with database design. Like I said, you don't really need your laptops for this. So if you wanna save some battery, feel free to just put them off. We'll start with some basic definitions about databases. So, I mean, how many of you guys have heard of databases before? Or at least a little bit familiar with them, you know? I guess those of you who are taking the class right now probably know the basics. Some of the beginning, some of this stuff might be familiar to you. But for those of you who are not familiar with this, a database is a collection of related data. And that's, the word related is really important because it can't just be any kind of info. It has to be stuff that makes sense, that's related. That's why it's called that way. Then data are, facts, information about different things in the world that can actually be recorded, and they have to have a meaning. It can't just be any abstract information that you're going to put in a database, because that wouldn't work. Then we have what we call a mini world. A mini world is part of the real world, and this is what you base your database out of. So you can make a database out of the whole real world. You have to pick a certain part of it, and that's where you make your database out of. All right. So for example, a mini world might be a university. So for a university mini world, you probably have things like departments, students, professors, faculty, different things like that. And here's a diagram of what a database system is. So pretty much what a database system is, it's both the DBMS, which is a database management system. PostgreSQL is a database management system. And you also need the data to work with the DBMS, because if you have no data, there's nothing you can do with the DBMS. And both of these together make up the database system. Then we move on to the database structure. So we create data models for our databases, and these are a group of concepts that are used to describe the whole structure of the database. And so there's different parts to this structure. There's 3 of them. One of them is data types, relationships, and constraints. Okay? And we'll be going over each one of these in the following slides. Data model, there's different operations you can do in a data model, and they're used to specify certain retrievals and updates that you want to make to the data model. One of the data models that's most commonly used is the entity relationship data model. We call it the ER data model. The concept is that it provides the concepts that are close to the way that people perceive things. And that's the reason why SQL is so intuitive, because, by the way, if I say SQL, I mean SQL. I know they're kind of used interchangeably, and what I found mostly is that here in academia, they mostly say SQL, like in classes, probably in your classes it's like SQL. But in the workplace, a lot of people are just used to saying SQL, all right? So when you go out in the real world and you go get to an internship or a job opportunity, you'll hear a lot of SQL instead of SQL. But they're both the same thing. That's two different ways of calling it. Like I was saying, the data model that's used is the ER data model. It's very intuitive because it's super easy to create queries based off of this model. And there's different concepts that make part of the ER model. One of them is entities. So entities are things like departments. For example, in a university setting, it'll be the departments, the students, faculty. Entities can be either strong or weak, and we'll be going over that in a few slides. We also have attributes. Can anybody tell me what attributes are? Or why do you think they are related to entities? No? So attributes are like the qualities of the entities. So let's say for a student, there's different kinds of attributes. You could say their name, the first name, their last name, their address, their social security number, their Panther ID, all these different things. So those are attributes, and each one has a different kind. So there's a simple, there's a composite, multi-valued, key, and derived. So again, we'll be explaining these in the following slides. There's also relationships. So when you have all these entities and they're all related, they have to communicate to each other in some way. And the way you do this is through relationships, right? And there's both strong and weak relationships. And also, because you're dealing with a mini world, you have to put some constraints in that database. You can't just leave it without a constraint and use the database that way. It won't work, all right? So in the following slides after this, you're gonna see a lot of diagrams, and I just wanted to put the notation for most of these diagrams. Some of these you kind of don't really have to know, but the basic ones, for example, the entity, it's pretty much a rectangle that you draw to put on an entity. Relationship's a diamond shape, and an attribute's just an oval shape that you draw on the diagram, all right? The other ones you don't have to worry about too much, but still we're going to give you a couple of examples so you can see how those are used. All right, so first we're going to define the entities. So there are specific objects in the mini world that are represented in the database. So like I said, students, departments, and things like that. Entities have properties that describe them. These are the attributes, right? So a department, for example, would have a department number, a name, the employees that work in it, things like that. Entities with the same attributes are grouped into an entity type. So an entity is like a single instance of the entity type. So let's say I have a department. The department will be the entity type, and the entities will be business department. Another entity would be engineering department, different things like that. But the type of entity in overall is the department. So those are all departments that you have under that entity type. An entity type defines a set of entities that have the same attributes. So again, since you have different departments, you have the College of Engineering, you have the School of Business, you have all these different things. They all have to have the same attributes in order to be considered under departments, right? So that's how the entities work. So for example, here in the diagram, you can see for departments, you have research department, sales, marketing. For employee, you have different names of different employees. For dependents, same thing, different names of the employees' dependents. And for projects, you have different kinds of projects that work for that company, okay? And this is how you would draw a diagram for the employee entity. So like I said, the entities go in a rectangle, so you have the employee, right? And this is like the very beginning of your database, pretty much. So you have to define the entity, which will be the employee. Then you have the attributes, which are in an oval shape, right? So we have name, which is one of the attributes. And like I said, there's different kinds of attributes. So this one's composite. And composite means that there's different parts to it. So there's a first name, there's a middle, and there's a last. So this is why that's a composite attribute, okay? Then we have a social security number, SSN. This is a simple attribute because it's just one string of numbers, so it's simple. And the reason why it's underlined, it's because that attribute has to be unique. And for this, it makes sense because every employee, every single person has a different social security number. Nobody can have the same social security number. So that's a way to identify that entity within the employee department. Then you have the department number, which again is simple. You just have a number, which would be like 5, 4, 3. You also have a degree, so whatever degree you have, like a BS and CS, an MBA. If you have multiple degrees, then that's when the attribute becomes multi-valued. So that's why this one for degree, you see simple and multi-valued, because each value is simple, but you have many of them. So that's why you have a multi-valued attribute. And then the last one, it's number of employees. This is a derived attribute, and what that means is that when it's pretty much derived from any other attribute. So you can see what the number of employees are based on how many SSNs are there on the table on the in that relation. Okay. So are you guys good so far? I'm going too quick. You guys are kind of getting it. Yep. So I want to make sure I really go like through the basics and you get like every single thing, because I know it's when I took the class, there was a bunch of things thrown at you, so it's a bit hard to understand at first when you get so many different names, different keywords, and all these things. So again, it's really important that you get that the rectangles are the entities and the circles are the attributes, and the attributes are properties of the entities. Okay, and there's different kinds of attributes. All right. Oops. All right, so I kind of went over this a little bit, I guess. For attributes, again, those are properties that describe the entity. A specific entity will have a value for each of its attributes. And there's 3 types: simple, composite, and multi-valued. So here I'm highlighting the different attributes again. So I think we're pretty good with this so far. Next is the relationships. So when you have different entities, you need to have a relationship for a way to communicate both of them and get data from both at the same time. So again, this relates 2 or more distinct entities with a specific meaning. So they have to be distinct. They have to be different. They can't be the same entity. And they can be more than 2. It doesn't have to be just 2. It can be 3, 4, 5. But the more you do it, the more complicated the database gets. So it depends on how you want to design a database. Relationships of the same type are grouped into a relationship type. So for example, here you have a works for relationship. So you can say that the employee works for a department, right? So every employee, like let's say John Smith, he's going to have one instance in that works for relationship. He's going to say John Smith works for, let's say, the research department, right? Let's say you have a Mary Jones. Mary Jones will have a different instance of that. Mary Jones might work for the engineering department or something like that, okay? Then we also have a manages a relationship. So again, you can have more than one relationship between 2 different entities. So if you have employees, they obviously have to work for some kind of department, right? But there's also a few employees who are the managers, and they will have to manage other departments. So that's why you have 2 different relationships going on there. And from the relationships, you can also get additional data that you might not be able to get just from the table. So for example, if you have a works for relationship, you can get the hours per week that the employee worked. So in this case, it'd be 40. You can extract that data from the relationship. And also another important thing are the degrees. So these are the number of participating entity types. So for works for, it's degree 2. And why is it degree 2? Can anybody tell me why? Pretty simple. So again, degree is the number of participating entity types. So how many entity types do we have here? We have 2, right? So employee and department. So that's why the degree for works for is 2, and also why the degree for managers is 2. Like I said, a relationship can have its own attributes, like you see the hours per week for works for, and more than one relationship can exist with the same participating entity types. All right. So far, what do we have? We have entities, we have attributes, and we have relationships. Those are, I would say those are the 3 key things you really need to know in order to create a database. There's also some other things, details that we'll go over. And one of those are constraints. So like I said, you need some kind of constraints to keep the integrity of the entire database. You can't just put out data and expect it to work when you want to query it back, right? So a way to do this is to have structural constraints. And the structural constraint that's used for pretty much all the tables is the primary key. And the primary key is a unique value for each entity. So for example, for an employee, what do you think will be the primary key? Which of the attributes do you think we should make the primary key for an employee? Social security number, right? Oh yeah, I have a few stickers that we give out to you to answer questions. So so yeah, so all tables, all entities need a primary key. So that way we can identify them within the database. Otherwise, if you want to look for a specific record and there's no primary key, there's no way for you to figure it out. Because if there's two records that share the same data and they don't have a primary key, there's no way for you to get that. There's no way for you to see which one it is that you're looking for. All right. But there are some entities that don't have primary keys. So again, it's not mandatory, but those that don't, they're called weak entities. And the ones that are weak need to be related to another entity that's actually strong. So that way, when you look at the strong entities and the weak entities, you can relate both of them. All right. There's a point of relation between both of them. So if you look for the employee's social security number, then you can see their dependents, for example, because a dependent's a weak attribute. I mean, a weak entity. Another example, another kind of constraint is referential constraints. So you have foreign keys, and that's a value that references the primary key of another entity type. So for example, if you have an employee and you have a department, right? So the employee, under the employee info, you have social security number, you have names, you have all these things, but you also have the department number they work for. So let's say employee John Smith has, he works under Department 5, right? So then if you wanna see more details about that department, you will have to refer to another table, which would be the department table. And so the way for you to do that is to use foreign keys. So that way you can say, okay, on the employee table, John Smith works for Department 5, and then on the department table, you see that there's a Department 5 listed, and it has those details for Department 5. So the way for you to get a mix of both kinds of data from both tables is to just join the two tables through a foreign key, and that way you'll get one query with all the information that you need. Okay. And this stuff is is a little bit difficult to get, like I won't lie to you, but once you get into it and you practice a little bit, you'll understand what joining these things mean. And the primary keys, I think the primary keys are really basic to learn. You know, it's just unique pieces of data. So employee SSN, if you don't have any unique kind of data for some data set, what you could do is just create an ID number for everything. So if you have a list of students, and let's say that there's no Panther IDs and SSNs don't exist, then how would you differ from one John Smith from the other John Smith, right? You need some kind of a number or some kind of a property that's going to differentiate both of them. So the way you could do that is by having different IDs. So you have ID 1, 2, 3, 4, 5. That's usually the quickest and easiest way to do it. And here's sort of like a visualization of what I was explaining right now. So you have the employee entity with its own attributes, right? We made the SSN the primary key because, like we said, SSNs are unique. And the department number they work for is Department 5. And we're going to make that a foreign key. So that way, when we refer to the department that's right below, in that diagram below, we can refer to the number 5 for that department. And that way we'll know, let's say we have a query that asks like, what's the name of the department that employee works for, right? If you only look at the employee entity and its attributes, you can't tell what the name of the department is. You can only see the department number, which is 5, right? So the way for you to figure that out is to join both tables. And the way to join them is to have the same data on both. So you have the department numbers in the employee table, and you have the department numbers in the department table. So that way you join the same data and you can get to the name of the department, which is research in that case. Okay? So this is how you kind of visualize what foreign keys are. It's just a way for you to work with different tables and get information from different tables at the same time. Okay? All right, so here's an example of a company database. So for this, you guys are gonna need a sheet of paper just to like draw the different diagrams, as we're gonna do the actual schema of the whole thing, okay? So just grab a sheet of paper, get a pencil, because you'll most likely be erasing a few things. If you can, try to lay it out this way, because we have 4 different entities that we're gonna have to make a diagram for. As you can see, there are the employee, the department, the dependent, and the project. Okay? I'll give you guys a couple minutes. Okay, you guys ready? Alright. So, first we have the entities for our database. For employee, these are the things we can have. First names, middle names, last names, birth date, SSN, address, salary, and sex. So those are the different things you can have, different attributes for that entity. Okay? So this is our first entity for the database. And we'll get to draw it. So I'll try my best. I'm using a mouse, so it won't be perfect, but I'll try. Let me see. So how will we go about drawing this, right? What is the first thing you think we need to draw for the employee entity? Rectangle? Yeah, let me just think about it.
I see like the one where you can draw on that shows kind of like the papers. I see the two monitors. I have a computer on the left side. and
All right,
a
so
video
yeah, like he said, you have to draw the rectangle first, right? You need to know what the entity is. So we can draw the rectangle. I'll try to make it a rectangle. Again, you have try to have 4 different edges on your paper, so that way you can do the 4 different entities, all right? And then you have space to connect them all, because we're gonna connect them all. So this would be employee. I wish I had a whiteboard, but there's no whiteboard here, so we can't. I can't really draw it. So that's employee. There is one, but it doesn't look like a whiteboard. Huh? I got markers. Where's the whiteboard? Oh, this is actually a whiteboard. And it looked like something else to me. That's why.
Caesar,
All right. So we'll do it on the whiteboard then. Huh?
I'm giving you a microphone right now.
Okay, cool. We're gonna try to get a mic as well, so that way I don't lose my voice. So the last one, I guess, is we can actually probably this thing. Project? This thing? Does it work? I don't know. I mean, I can do it on the board, that's fine. Oh, I see what you mean. Yeah. How does this thing work though? I think it's. Let me see. Let me try it.
I'll leave you with one.
Okay. All right.
It's only 10 minutes.
Oh yeah, you're right. All right, cool.
You're not going to see.
Yeah, try to bring it this.
This is my phone. Yeah, that's my microphone. That's the one I'm using for the project. That one, if like that's what I was telling people, if you're having trouble hearing in the back, just log on to the live stream and you're gonna get. Someone in right now. No, I appreciate it. It's just they were supposed to bring. They were supposed to bring some order.
It's easy to connect. You have like an amplifier.
No. They usually the
guys see that? Wait, let me see. Hold on. Go down. Zoom out. Oh, there we go. All right. Perfect. Good. All right. So you can put employee in here, right? Employee. So again, what were some of the attributes that you guys were looking at? Which ones should we include for employee? First name? Okay. So. Yeah, you can list the social security number as well. So, first name, say last name, SSN, right? What else are we missing? It's a middle initial, right? And again, you can name these anything you want, but obviously you try to name them as close as you can to whatever it actually is, so that way you can identify them, all right? So you can say middle init, you can say initial, you can say last, first, whatever, it's up to you. What else do we have? So SSN, address, that's another one too. Address. Right. Salary and sex. Right. Huh? Birthday. We're missing birthday. Yes. So birthday. Okay. All right. So since we said the SSN was the primary key, there's a way to differentiate it from all the other attributes. And the way you do that is by underlining it. So you underline it, and that way you know that that's your primary key. That's a unique value that every employee has, all right? The other ones can't repeat, that's fine. The database will be fine, but it's just the SSN that cannot repeat, all right? Otherwise, the database would just go haywire and go crazy. So employee, and what is the other entity that we were looking at? So we have employee. What else are we missing? We're missing 3 more, right? Department. Department. Right. So what department number will be under department, right? Or employee? Yeah. SSN, department. Under department, it would be, I think. So let's try. Yeah. So you can have a department number. So you can say DNO. That's something that's written a lot. So DNO, it's foreign key. If you have a foreign key, what you could do is you can just write FK next to it. That way you know that's a foreign key. Birth date, I don't think that's not going to be a foreign key because all the other entities don't need to know what the birth date is. First name, last name, middle, same thing because they're going to repeat, so it's not going to be useful. Address, same thing. Salary, same thing, and sex, same thing. Because those are going to repeat a lot, so there's no reason to make them a foreign key or a primary key. All right. But department number, if we have the employee's department number, then we can connect to the department entity, right? So now we move on to the department then. So we have department. Let's see. So for department, which attributes do we need? What's unique about a department? Department name, all right. So again, the thing is that what if you have different locations and they have the same kind of department? You have a marketing department in Miami, you have a marketing department in New York, right? So then they will kind of overlap. So a way to solve that is to have 2 primary keys that go along together, and that way you can differentiate them. So let's write name, and then the thing that's used the most again is a number. So if we have a department name marketing and we have a number 1, we know that that's, let's say, from Miami, right? And then if we have a marketing department that's number 3, then we know that's the marketing department from New York. So that way we can differentiate both of them, all right? So that means that we have 2 primary keys. We have name and number, all right? And they both need to be entered at the same time. Because otherwise, if you have two different you have two of the same names, you can differentiate them in the database. What else? No, so speaking of the different locations, that's another attribute you can add. So locations. But the thing with this attribute is that for every record, you won't just have one value for locations. Like let's say it's a marketing department, you can have locations. You can list Miami, New York, LA, all these things. So that means that that attribute is going to be multi-valued. And the way to indicate that it's multi-valued is by circling it one more time, right? So that means that location like that, that's multi-valued. And one last attribute we got was the number of employees, right? So number of employees, and it's like that because it's a derived attribute. You can get the number of employees just by taking a look at the different SSNs and getting it that way per department. So we have department down. What's next? We have a project. There's a project entity. There's also an employee department. So employees, they work for departments, but they also work on projects, right? So we can say there's a project entity. Okay, so that'll be project. And for projects, you have 3 different kinds of attributes, at least for this database. Again, like if you're going to create your own database based on a university, you can add all the attributes that you want. You can add as much detail as you want. It doesn't have to be exactly this way. It's usually up to the database designer to choose what they want on the database and what works best for that client and that situation you're in, all right? So for project, you need obviously a name for the project, right? You also can use a number for the project. That way you can differentiate it. So we can have a number. And again, there might be 2 projects with the same name in different locations. So the way that you differentiate them both is by doing 2 primary keys like we did for the department. Okay? And then the last thing for the project is the location. So we have a location for that project. Okay? So that's it for project. And the last one is dependence. So dependence. For a dependent, you would have a name, right? You have a name, that's an attribute. Sex. Birth date. And relationship. So relationship will pretty much just say whether the dependent is, you know, the mother, the father, the sister, the son, the daughter. So any, what kind of family relationship they have, okay? And for the dependents, there is no primary key because there can be different dependents with the same name. And same thing with sex, they repeat a lot. Birth date, they can both be born on the same day. And there's a relationship, they can both be, let's say, 2 sons, right? So that way, that's why there's no primary key for the dependents, all right? And because of that, it's a weak entity. And what we do with weak entities is that we draw another rectangle around it, just like we did for the locations up here, okay? So now we have the 4 entities, and I'm gonna switch back to the laptop so you can see what I got here. Okay. So now that we have the entities, we have to relate one another, right? So that's what we have relationships for. One of the first relationships can be employee and department, right? So like I said before, an employee works for a department, right? That's one relationship. And a department is worked by an employee. So it's gotta work both ways. An employee works for the department, and the department is worked by the employee. You also have an employee manages a department, and the department is managed by an employee, right? And when you have that relationship, you can see what the start date of the manager was, okay? You can also have relationships with the same entity. So for example, you have employee supervises another employee. So that will be an example of when you have a same two of the same entities in the same relationship, okay? So that'll be supervises. This is what we will call a recursive relationship because it relates two entities of the same type, okay? And this can happen a lot, and it's perfectly fine. It's just a matter of setting it up right so the database doesn't mess up. Then there's also employee works on a project, right? And the project is worked on by the employee. And through this relationship, we can see the number of hours that the employee worked in that project. Then we have department controls the project, right? And project is controlled by a department. And the last one is employee and then you have dependent of, dependent. So that's when you connect to the dependent that has no primary key. And when you have a relationship with a weak entity like dependent, you have to create what is called an identifying relationship. And that's why that diamond shape is it's done that way, because it's a weak relationship. It's an identifying relationship. It means that the only way for you to get that information about the dependents, it's for you to go first through the employee. Because if you don't go through the employee, there's no way you can access that data. All right? So ideally, this is what our database should be looking like with all the different relationships. There's a lot of stuff going on this one. We have some things like constraints and more specifics that we'll go over later. But pretty much the gist of it is just that you have the entities and you have the relationships, right? So we're gonna draw them all on the diagram we have here. So let's see. So yeah, gotta switch. All right. So now we're gonna connect all these. So first one is employee who works for a department. So you would do this. You will connect. Can you guys see that? Yeah. Okay. It's green. So. All right. Then you have to draw a diamond shape for that, and connect it to the department. All right. So relationship. It has to be a diamond shape. And this one would be works for. Right. So an employee works for that department. All right. Then the next one is an employee manages a department. So like I said before, you can have more than one relationship between two entities. So if an employee manages a department, then you would have to do another one of these. I know some of these things are going to overlap, so it'll be a bit messy, but just so you get the idea, you'll have another relationship here, right? And another connection to it. So this will be manages, right? So you have an employee who works for a department and an employee manages that department, okay? Again, not all employees are managers, only some of them, so that's why you have two different kinds of relationships. And works for, you would need every single employee to participate in that relationship, right? Because every employee has to work for some department. And for the manages relationship, it's only going to be a few that are going to fall under that relationship, okay? Another one I mentioned was the recursive one. So employee supervises another employee. So in this case, what you could do is draw one line down here, have a diamond shape, and let's say it's manages, right? Oh, I'm sorry, it's supervises. So an employee supervises another employee. So how do you think we should go about that? Should we draw another employee entity, or what should we do? Just go back to it, right? So you can just draw another line and pretty much go back, right? So that's why it's recursive. It just goes back, all right? For supervises. Then we have employee works on a project. So we would need to draw another one that goes down here. Employee, let's say, works on a project. And when you know that an employee works on a project, you know how many hours they work for that project. So you can get an attribute out of the relationship. So you can do hours, let's say, right? So you can see how many hours they worked on a specific project. And it was actually the same thing with employee managers department. So for this employee managers department, you can see what the start date of the manager was. So start date for that manager. So as you can see, relationships also have attributes. You can get a lot of data, a lot of information out of the relationships. All right. The next one is department controls a project. So you have department and project. So we have to kind of go across now. So a department controls a project, right? And the last one is employee is a dependent of has a dependent. So for this, again, it's kind of messy, but you will do it this way. You will go here and then do dependent of this dependent, right? And again, since this is an identifying relationship, because it's weak, we have to do another diamond shape around it. So that way we know that in order for us to get this info here in the dependence table, we need to go through the employee first. So once we get through the employee, then we can go to dependent of and dependence. So I guess you could say this is kind of isolated in a way. Unless you have access to the employee table, you can't get to this because there's no primary key here. There's no way for you to get the info you need out of it. All right. So so yeah, that's pretty much what our diagram should look like. Again, when you probably do homework and stuff and you do it the first time, it's going to be a mess like this. And then you'll figure it out and see, okay, I can probably place the dependents below the employee, so that way I can draw the line this way and I can put the project on this side. So that way it looks nice and it'll look more like the diagram that's on the PowerPoint. Like this one, right? So it'll look more like that. Then you also see these numbers here, like 1 and 0, 1. Those are the participation constraints, structural constraints. So there's a participation notation. So for example, like I was saying, an employee, for managers, there's a 0 and 1, right? If you see the line going from employee to managers, there's a 0 and a 1, right? The 0 means that there's a possibility that none of the employees are managers. So there can be that possibility. And then the max number of employees that can be a manager is 1. So if you have an employee that manages a department, they cannot manage another different department. They can only manage one department. So that's why for that relationship managers, they're only going to show up once. So pretty much what that's telling you is that employees, they might not show up at all in managers, but if an employee does show up, it can only be one time. And that makes complete sense because if you have a manager, they can only manage one department, right? At least for the most part, that's what people do. So same thing with the other one. So you have employee who works for a department, so the one that's up there, right? So this is a one-to-one relationship, and that's because every employee has to work for a department. So the least number of employees that can work for a department is 1, and the max number of employees that can work for a department is 1. So you have a 1-1 relationship there, okay? So there's different notations like that. You see some of the underlining. That's the underlining is, again, a primary key. If you see 2 circles, those are weak attributes. If you see 2 diamond shapes, those are the weak relationships. And dependent, for example, you have 2 rectangles. That's a weak entity, all right? So yeah, and like I said, you can add as many entities to this as you want. It all depends on what the client, like I say you go to a client, they're like, okay, make me a database for this. And they have to tell you the specs, everything that you need for that. And based on the specs, you have to create different constraints. So it might be perfectly acceptable to make, an employee, to have no managers, so that an employee would be like 0, 0. So there's different kinds of things that depend on the mini world, depend on what the client needs for the database. All right. Okay, so I think we're gonna take a break. Yeah. The n? Oh, so the n is like any max number. There's no max, just any number. Yeah. So it's 0, 1, and n. N is just any max number. Okay. So yeah, we have some snacks here for you guys. So feel free to like line up and grab some. We'll have like a 10-minute break, and then we'll go to the stage.
What program do you want us to use for the second part?
The PostgreSQL. That's the one that's used for like most classes, I think. Well, at least when I took it, it was that. So. But it's really up to you. I mean, as long as it's SQL, it's fine.
We can use that for Windows.
For Windows, yeah, it's for both Mac and Windows. Yeah.
They give you two options. Do you know which one we have to download?
I know there's a Stack Builder. You have to download Stack Builder. I think it's Stack Builder. That's one of the installations. I mean, there's a Mac, Windows. There's a bunch of versions for it.
Yeah.
So just whichever one you need, that's the one you download. That's really it.
You might want to mute the stream, by the way. It's showing everything you're seeing. Give me 1 second, I got you. Okay. When we start, switch back to that scene and then mute the mic.